Okay, guys, welcome back to my course of Unleashing the Computer System's Basic Concepts. Okay, let's start with the monitor. The monitor is a display device that also is a conjunction of many other things. It's not just a single device. It has the display, it has circuitry, and it also has an enclose. So it's the conjunction of the three things that makes a monitor. I'm following here the Wikipedia definition here because it's the most exact definition that I could find. Okay, let's see the three common techniques that are used to build monitors. Well, the oldest one is the cathode ray tube, the CRT. It's a very old technique, was developed at the beginning of the 20th century and the ending of the 19th century. We have also the liquid crystal display, the LCD. That is another modern technique. It was developed end of the 20th century and the beginning of the 21st century. And a newer one that is similar to the LCD technology is the organic light emitting diode, the OLED, what we usually call LED display. It's not a LED display, it's organic light emitting diode, but we can say it's a LED display. We'll see that there is some minor differences between LCD and the LED monitor, but we'll cover this in detail later. The basic monitor concepts that we are going to cover are here. These concepts are very important for us because we can measure how good is a monitor compared to another monitors. Well, the bezel is the enclosure that the monitor has. So it's generally a metal or plastic frame, but it can be made of other materials. The bezel is generally not a factor that we are trying to compare because it's generally not what interests us most. We have the contrast radio. This thing is very important. It says how can we measure the difference between the light intensity between the white and black colors in the LCD and LED display. It also happens to have a contrast radio in the CRT monitors, but we cannot compare them to the LCDs. You'll see later that they have very different technologies. We cannot compare contrast radio, unfortunately, as we can with the LCD and the LED. Well, the higher contrast radio, it's easier to see the details because it makes what is white whiter and what is black blacker. So the colors become stronger. Well, we have a very unpleasant effect called ghosting that happens in the monitors. This effect doesn't happen in the CRT monitors. It only happens with the LED LCD monitors. We'll see that its effect is caused because we have a slower response time to the image change, and this slow response time causes blurring in the image of the LCD or LED monitor, and this slow response time is generally called latency. Well, this can be because there can be a voltage peaking from the energized elements of the monitor. We'll see that these energized elements, we are calling them here pixels. These pixels we are gonna cover later, what they mean, what they are. Luminance is the brightness level of the monitor. So, what's the main difference between brightness and contrast radio? Brightness is the overall white color of the monitor. Even if you have a black color, if you increase brightness, this black will become brighter. It will become whiter, even if it's black. So it changes the whole monitor. It doesn't change only one color when compared to the other one. So it's different from the contrast radio. It's generally measured in nits and candelas per square meter. Let's see the other one. We have the native resolution. Native resolution is the actual measurement of the LCD display in pixels is given in horizontal by vertical order. Well, what this means for real? This means that if you have a higher native resolution, you have a higher quantity of pixels. These pixels are the minimal unit that your computer can use to display image. So when you see a small square in your monitor, this very small square is called pixel. So the bigger the quantity of pixels you have in your monitor, the better the image will be, because you could have smaller squares, and these smaller squares can lay out better and can just display objects better, because you won't have those sharp points in your image. We have the response time. The response time is what we call here in the ghosting. This ghosting is caused because of the response time. But what it is a response time? The response time is the speed at which the monitor pixels can change colors. So if your monitor receives from your computer the voltage needed to change certain pixels, it has a delay when processing this information through the electric circuit and displaying it in the display itself. This generally is measured in milliseconds, but you'll see that even with so low delay, it can cause big differences in the images. We'll have also the stuck pixels that we can call dead pixels. These stuck pixels are pixels that cannot change. They are pixels that are always illuminated or always in black state. They generally are called dead because you cannot control them. If you see, for example, one little dot green in your screen that shouldn't be green in that position, you see that this pixel is called a stuck pixel. It's called a dead pixel, and generally you cannot do anything to fix it, but you may fix it if it is a software problem in your monitor. If it's not, you unfortunately will have to deal with it or change your monitor if you have it under your warranty. Well, we have the VESA mount. The VESA mount is a support where you can mount your monitor in a wall or in a desk. So it's basically a standard for your screws positions. We have also the viewing angle, is the angle at which you can view the screens. So, for example, if you change the angle you're looking to your screen right now, you see that at certain angles you cannot see the image very well, and in other angles you may see them better. You have a vertical one and you also have a horizontal one. Well, here we are going to talk about how these three technologies work for real. First of all, this image here is about a CRT monitor internal operation. It was acquired from the How Stuff Works website. And here at the A position, you'll see that we have a device called cathode. This cathode device will emit a beam of electrons. This beam of electrons will pass through the C device. The C device is the anode device. This anode device will generate a potential difference here when compared to here. So you have a voltage here and a voltage here, and this difference between these two voltages will cause these electron beams to deflect, and the way they deflect will be used right here to display the image. But how does this work? Well, you'll have three electron beams here. One of them will be the red one, the other will be the green, and the other will be the blue. These are the three basic beams that you can produce with the cathode. Well, with these three beams, you can display any color that you may want in a single point of your monitor, depending on how these beams are deflected and their intensity. Here at the B position, we have a conductive coating. Well, what do we call a conductive coating? It's basically a material that allows us to put some voltage in it and cause this deflection that I told you about. The anode makes the main deflection, and this material here also helps in this process. We have here the D part of this picture is the phosphor coated screen. This phosphor coated screen serves the way that when the electron beams hit this coated screen, this coated screen goes on, and you'll see a brilliant color being emitted from it. So the electron beams you cannot see, but when they hit this coated screen, you'll be able to see the image. So it's generally chemistry. Is electrons hitting this coated screen will emit color, visible color. Well, the E part are the electron beams that I was talking about. The F part is the shadow mask. Well, what is the shadow mask? Shadow mask is just to make sure that you have a perfect pixel right here. So you can see here that this little thing here is a pixel. It's the minimum unit that your monitor can display color. So depending on how these beams are hitting this part, you'll see or not see a determined color. You may see pink, you may see red, you may see brown, depending on how these three beams are hitting each of these little squares here. Well, this is the CRT monitor technology. Well, let's now talk a little bit about the LCD technology. So let's see if I can, oops, it doesn't work. Let's open it right now. This is a flash animation that will show a little bit how the LCD works, the LCD monitor works. Well, this is the basic image that you have about a LCD display, and let's explain it a little bit. You have here at the background a big bulb, light bulb, that will produce light, white color, and this light wave will pass through this polarized panel, the first polarized panel inside your monitor. Imagine your monitor as a matrix. This big matrix will have many rows and many columns. Each column and each row can be precisely activated by voltage levels that the monitor engineer will define what levels are these ones. And depending on what voltage the engineer applies in each combination of rows and columns, you'll see a different color in a specific pixel. Basically, when you apply voltage to a row and column in your LCD monitor, you are changing how these polarized panels are positioned between each other, and this will allow or does not allow the light wave to pass through the monitor. So at this position, the polarized panels allow the light wave to pass. If I change the position through the electrode that I was talking about, that is basically a row and a column, and if I change this voltage in these electrodes, I'll basically block here the light wave. Well, this is processed because we have a material here that we call a liquid crystal. So when current passes by this liquid crystal, it allows this light wave to pass through. If you don't have current, it just doesn't allow this to happen. So with current, it passes. Without currents, it doesn't pass. It's simple like that. Well, this is the LCD technology. But what is the difference between the LED technology and the LCD technology? Well, the LCD needs this whole thing here to make a filter to allow determined colors to pass and other colors will not pass, depending on how the voltage levels are inside this liquid crystal. Well, the LED technology is kind of different because you won't have a single light at the background here that we have with the LCD, you have many lights. These lights, the small lights, will be called LEDs because they use light emitted diode technology to produce light. We are not talking about this technology right now because it will be too much information to grasp. But for you, you can think of a LED as a device that when current is applied to it, it will display light. But these LEDs are projected in a way that they can produce these three colors that I was talking about in the CRT monitor. The three main principal colors, the red, the green, and the blue, are produced by the LEDs in the LED monitor. This is produced by voltage levels also, but you don't have to filter them. The engineer has the total control of each pixel in the screen, allowing each pixel to produce a determined color because each pixel have a single LED to it. It doesn't have a whole light bulb as the LCD. It has many light bulbs, smaller ones. But taking this aside, you won't have the filter that LCD has, so they consume less power than the LCD. Well, here's a little comparison between the LCD and the CRT. Well, the LCD requires less power, is smaller and lighter, and is more adjustable, and it also allows us to have less eye strain. That's basically because the CRT technology produces many light waves that we cannot see because they are not between the range of colors that the human eye can see. So the CRT monitors produce radiation. This radiation hitting your retina can cause eye tiredness that we call eye strain. Your eyes start to not like so much light being emitted to it. The CRT is cheaper. It has better color representation because it's analog device. Here's a digital device. You only have two options. You have pass or not pass color. So you can allow the red color to pass, the green color to pass, or the blue color to pass. You don't have another option. You allow or you don't allow. Here we have a middle option. You can allow a little bit of color, of red color, green color, blue color to pass. You have this little difference. Well, CRT is more responsive also. It has a lower response time, and also it has a lower ghosting effect too. That's basically because, like I was talking to you, it's an analog device. It doesn't have electric circuit so much complicated like this one has, so it's faster to respond. It also accepts many resolutions, so you can have many pixels, many different combinations of pixels in your screen. In the CRT monitor, here we have less combinations. That's what we call, here you may have HD, you may have Ultra HD, you may have Full HD, and other resolutions. But here you may have XWGA, WGA, VGA, and many others resolutions that the LCD doesn't allow. Well guys, thank you for watching this video, and if you have any questions, please visit my website or email me at this address. Thank you, and I'll see you later in my next course video.